Hi everyone, Mrs. Tatter. So in one video, I already went through the rules for sine, cosine, and tangent. In a different video, I went through the Pythagorean theorem and how you need to simplify your side so that sometimes it still has a square root in it. This video is something that happens when we are dividing and there's a number with a square root in the denominator. And that's going to happen sometimes. If you remember, sine, cosine, and tangent all have to do with different ways that you divide the sides of a right triangle. So this is only going to be necessary if your denominator has a square root in it. So I'm just going to make up a problem. So let's say I'm doing sine, cosine, or tangent, and I wind up with 5 over the square root of 3. You can see that my denominator does have a square root sign. So basically what I want to do is find a way to kind of get rid of it. Sometimes this makes the fraction simplify even further. Sometimes it doesn't do anything. I'm not really sure why mathematicians decided this was necessary, but it's just one of those things that your answer choice is going to look a different form than this. So the easiest way to get rid of a square root is to square it. Now, I don't necessarily want to like square this whole entire thing. I guess technically you could, but you really need to multiply by a value that's still equal to 1. If I start multiplying the numerator and denominator by different things, the value of my fraction is going to change. And I don't want to change the value of the fraction. I just want to change the way that it looks. So I'm really only going to worry about how to get rid of that square root in the denominator. So I can get rid of it by multiplying the denominator by itself. But whatever I do to the bottom, I have to do to the top. And so here, this is my value of 1. Anything divided by itself is technically equal to 1. So my numerator, you cannot multiply together a whole number times a number that's under the square root sign. It would be like doing 5 times x. It would just be 5x. So this is just going to be 5 squared root of 3. I'm going to do this in 2 steps so that you can see it, but the 2 steps are not really necessary when you're working them out. I can multiply numbers that are both under a square root sign. So I can multiply those 2 3's together because they're both under a square root. 3 times 3 is 9. Well, the square root of 9 is 3. So my new denominator is 3. And this is why I said sometimes you can simplify it even further. 5 over 3 does not simplify, but sometimes you can reduce those 2 whole number parts and the fraction itself starts looking a little bit smaller. But this fraction here and this are equal to each other. And in a multiple choice situation, this is the way that your answer is going to look. All right, so let's do another example. Let's do an example where the denominator has a whole number piece, but it also has a radical. First, personally, I would look at the 2 whole number pieces and see if they reduce, but 6 over 5 doesn't reduce, so I'm going to have to keep going. I can see my denominator does have a square root, and that's the only thing I want to get rid of. So you're always going to multiply by whatever the square root piece is. So I'm going to multiply this by the square root of 2. All right, so again, my numerator, nothing too fancy. This is just going to become 6 square root of 2. And my denominator, when I multiply those 2 together, 2 times 2 is 4. So this is going to be equal to the square root of 4. The square root of 4 is 2. So my new denominator is 5 times 2, which is 10. All right, so again, what I did was I multiplied the top and the bottom by the square root of 2, because that's what I want to cancel out. You always multiply by itself. And it basically just always becomes the number that was under the square root sign. So you can see even in the first example, when I multiplied that, my denominator just equaled 3. When I multiply by that, it just equals 2. In this case, I had another piece in my denominator. I had a whole number part in front. So that means 5 times the square root of 2. Well, now throughout that whole process, I broke it down to just 2. So 5 times 2 is 10. And in this case, I can simplify my whole number pieces a little bit more. 6 and 10, I can divide those both by 2. 6 divided by 2 is 3. That part stays alone. 10 divided by 2 is 5. So again, you might have this set up on your paper, and that is totally correct. And you guys know, in a situation where you are sending me your work, I'm still going to give you full credit for having this answer. But on quizzes, and if I give you a study island or something that's multiple choice, this is the answer, the way that it would look. All right, so that process is called rationalizing the denominator, and I will give you some opportunities to practice that skill as well.